15 gemstones humans tried to destroy, but became more valuable. 15 gemstones from around the world share one hidden truth. Humans tried to destroy them, and that destruction made them more valuable. Some were burned in fireplaces. Some were crushed during metal mining. Some were misidentified for centuries. Some were thrown away as useless waste, and one was discovered only after its original form had already been destroyed. These are not ordinary gemstones. They are survivors of accidents, mistakes, and forgotten histories. Stones shaped as much by human hands as by the earth itself. This film uncovers how each one nearly disappeared, and why that near disappearance is the very reason we treasure them today. Ranked 15th, Tiger's Eye, Legacy. Smoke curled upward from an ancient stone courtyard, where pieces of golden brown mineral were placed into a ring of fire as part of a ceremony meant to guard villages from unseen forces. In the trembling light, Tiger's Eye entered history not as a mineral, but as a cultural relic born from belief. To the people who carried it, Tiger's Eye resembled an organ of sight from something beyond the human world, an unblinking pupil set inside desert rock. Turning it to ash was believed to blind misfortune itself. But the stone didn't submit. Inside every piece, ancient crocodilite fibers, once blue, once fragile, had been transformed by geological pressure into a lattice of golden quartz. Fire did not consume the structure. It clarified it. What was meant to be erased emerged more luminous than before, its internal bands sharpened by heat, its silky sheen intensified, as if acknowledging the flames rather than resisting them. Centuries later, in the colonial expeditions of the 19th century, Tiger's Eye resurfaced inside forgotten burial mounds and volcanic rubble fields. Historians discovered bowls filled with half-burned fragments, too smooth and too intentionally placed to be debris. Some were cracked, some had fused edges, but every piece held the shimmering phenomenon known today as chatoyancy, a wandering streak of light that moves across the surface like the iris of a living creature tracking its surroundings. What early civilizations tried to destroy had in truth been refined. The modern lapidary understands what ancient ritualists could not, that heating Tiger's Eye reorganizes microscopic fibers, polishing them from within controlled fire, like the uncontrolled fire of old rites, can deepen its honeytones, bleed blue into bronze, or push yellow into sharp glass-like gold. Collectors now search obsessively for the rare ritual pieces. Stones still bearing the uneven discoloration of ancient burning. They are flawed by human hands but perfected by time. Heirlooms of belief, shaped by both geology and ceremony. On the market, these specimens command prices far beyond their unaltered counterparts, coveted not merely for beauty, but for lineage. Tiger's Eye became valuable not because it survived destruction, but because destruction became part of its story. The burns, the thermal scars, the uneven luster, each detail is a record of human fear, reverence, and misinterpretation. The stone carries the memory of cultures that once stood between firelight and darkness, hoping an offering would guard them for one more season. Among mineralogists and historians, Tiger's Eye is now regarded as a unique kind of relic, a gemstone whose worth is inseparable from the ceremonies meant to erase it. Every polished cabochon and every museum specimen bears the echo of those fires, the soft crackle of resinous wood, the chants carried on night air. It is not merely a mineral, it is a ledger of human intention. Where others shatter, fade, or melt, Tiger's Eye carries forward the legacy of those who misunderstood it, shining more fiercely today than at any point in its long, flame-tempered past. Ranked 14th, Blue Halite, the sea that refused to disappear. Every mine has its shadows, corners where light bends strangely, where dust drifts differently, where something that does not belong waits to be recognized. Blue Halite lived in those shadows for generations. To the miners who carved into Permian salt beds, the stone was a nuisance, a blemish on the clean white blocks demanded by merchants, a fault line in an otherwise predictable landscape of evaporated seas. When that improbable blue surfaced on the cutting floor, it was broken away with indifference, tossed into drainage channels, or dissolved in runoff water without a second glance. Its color was too unusual, too suspicious. Salt, they believed, was meant to be white. Anything else must be contamination. But the Earth is rarely so obedient. What miners discarded held within it a secret born 250 million years ago from an ocean that no longer exists. The blue that puzzled and irritated them was not pigment, not intrusion, not impurity. It was light caught in a prison of cubic symmetry, microscopic distortions inside Halite's perfect lattice, trapped wavelengths the way deep water traps the last moments of a drowned sky. Geologists eventually learned the truth, that minute defects, electronic vacancies formed during slow crystallization, scatter light into shades ranging from glacier pale to abyssal blue. The color was not a flaw. It was the memory of an ancient sea breathing through stone. The revelation came late. By the time mineralogists re-examined these deposits in the 20th century, countless specimens of blue halite had already vanished, destroyed by the very element the stone was born from: water. Every discarded fragment dissolved back into brine, erasing patterns that would never appear again. What had once been plentiful was now scarce enough to command display cases, auction catalogs, and scientific curiosity. Collectors seek blue halite not for durability. The stone is fragile, dissolving with the barest trace of moisture. But for ephemerality, it is a mineral that exists in defiance of its own nature, holding shape despite its longing to return to liquid. The value lies not in permanence, but in knowledge, the awareness that what survives has survived against all intention. Study a museum specimen and the geometry becomes unmistakable. Cubic chambers fold into each other with improbable precision, each plane a relic of evaporating tides. Internal fractures glow like submerged lightning. Some samples contain phantom inclusions, ghost-like hexagons where ancient salt water once pulsed, long before continents reshaped themselves. The stone's luminous architecture, so easily dismissed by centuries of laborers, is now the very reason it is treasured. Blue halites rise from mine waste to sought-after rarity is not a story of scarcity engineered by markets or museums. It is a revelation that unfolded slowly, first in laboratories, then in academic journals, then in the hands of collectors who recognize beauty in structures most eyes were never trained to see. And the irony endures. The most valued pieces today are the ones that should never have survived, the fragments that escaped the hammer, the runoff, the dissolution. They sit on velvet pads beneath climate-controlled glass, illuminated by soft halogen beams that reveal every spectral gradient from ice to midnight. What miners once destroyed unintentionally is now protected deliberately. What was misunderstood is now studied with reverence. What was dissolved, lost, forgotten, is now remembered for the delicate truth it carried within. That not all impurities are flaws, and not all flaws are weaknesses. Some are revelations waiting for light. Ranked 13th. Jet, the gemstone lost to fire. The soft crackle of fire consuming winter fuel once echoed through countless homes. A sound that marked the disappearance of jet, burned unknowingly for warmth long before anyone recognized what had been lost. For centuries across Europe, jet was not a gemstone. It was fuel. Villagers gathered it in baskets from coastal cliffs and riverbeds, prizing the lightweight chunks for how easily they ignited. It burned hotter than wood, cleaner than peat, and faster than coal. In cottages, shipyards, and salt-boiling sheds, jet vanished into flames with quiet efficiency, leaving behind nothing but a thin veil of smoke. To those who worked the shores of England, Spain, and France, it was simply black stone that burns, a gift for the hearth, not the hand. No one suspected that these carbonized remnants of ancient forests, compressed for millions of years beneath archaic seas, held a future far removed from kindling. By the time the 19th century awakened Europe to mineralogy, most of jet's accessible deposits had already been reduced to ash. When jewelers and carvers finally recognized its capacity for high polish and sculptural detail, they discovered a paradox. The very material they sought had already been erased by generations who never knew its worth. The consequence of that ignorance is visible today. Museum collections display beads and carvings so rare that their equivalents in nature no longer exist. Intricate Victorian mourning brooches, Roman pendants, and Celtic amulets sit behind glass because jet of that quality cannot be replaced. The cliffs where ancient forests fossilized into jet have been hollowed out, their veins thinned to memory. The stone's fragility adds to the cost of its loss. Jet fractures with a whisper, crumbles under careless pressure, and dissolves into dust when exposed to the wrong air. Yet it polishes to a depth so glossy that it seems not to reflect light, but to consume it, an optical abyss carved into an object small enough to hold in a palm. Collectors understand the rarity not in terms of geology, but in the mathematics of destruction. For every piece of jet that survives, thousands, perhaps tens of thousands, were burned, broken, or worn away. Its scarcity is artificial, manufactured unintentionally by centuries of domestic need. The value lies not in what was mined, but in what was lost. Archaeologists often compare jet artifacts to echoes. They are remnants of a material that once covered coastlines in abundance, now reduced to thin seams and scattered shards. Excavations uncover jet objects not as signs of wealth, but as signs of what communities chose to preserve. In a world where most of the material was destined for fire today, the surviving pieces are handled with near monastic care. Jewelry conservators store jet in sealed cases, away from fluctuations of heat and humidity. Scholars document every remaining vein along the Yorkshire cliffs with the same urgency reserved for endangered species. Once a stone of the hearth, jet has become a relic of irreversible consequence. What was burned for warmth is now displayed with reverence. What fueled ovens now anchors museum halls. Its value is the shadow of everything that could have remained, but didn't. Jet endures as a quiet testament to the cost of forgetting what nature gives, and to the strange truth that some gemstones grow more precious not through preservation, but through the long tally of what humanity has destroyed. Ranked 12th. Hemimorphite, the beauty forged by loss. Before it was ever understood, Hemimorphite was shattered into dust in the pursuit of metal. Its story begins not with discovery, but with the record of everything that mining erased. To those who labored in the tunnels, it was little more than an interruption, a brittle glassy crust clinging to ore bodies, shattering at the lightest touch, falling to pieces beneath the weight of picks and shovels. In industrial reports, hemimorphite appeared only as a nuisance, a variable to be removed, crushed, or discarded in pursuit of metal. The stone's fragility sealed its fate. When loads of zinc-bearing rock were hauled to the surface, hemimorphite never survived the journey. It splintered in carts, dissolved in wash water, or vanished in smelter fires, its delicate radiance erased by the roar of furnaces. It existed in mines as a whisper, and left them as dust. Only later did mineralogists realize what had been lost. Hemimorphite is one of the few minerals on Earth whose crystals terminate differently at each end, an asymmetry that defies the intuitive symmetry of most natural forms. One point tapers like a frozen droplet, the other expands into fan-shaped petals, as if the crystal were trying to grow in two opposing directions at once. The structure is so precarious that even temperature changes can fracture it. To form a single intact specimen requires an alignment of geological conditions so specific, so tenuous, that many deposits produce none at all. Where hemimorphite does appear in gem-grade quality, electric blues, oceanic greens, milky opalescence, it is often in seams so thin they can be lifted with a fingernail. And yet, for generations, these seams were ground away for the sake of metal. The sacrifice was not deliberate, only practical. Every mine represents a choice: what is extracted and what is allowed to disappear. In the age of industry, hemimorphite fell on the side of disappearance. Today, the few surviving crystals tell the story of everything that could have been. They rise from matrix rock like frozen waterfalls, fluid yet rigid, each blade translucent enough to catch the faintest trace of light. Some carry the hue of a breaking wave, others glow with the softness of clouded ice. Their surfaces bear microscopic ridges, growth lines recording the quiet rhythm of water seeping through ancient fractures. Collectors handle them as if touching time itself. A single vibration can undo millions of years of formation. A single mishap can reduce a museum specimen to shards. Even in perfect storage, hemimorphite ages, its luster shifting subtly as if remembering the stress of the mines it once endured. Its value today is not measured only in color or clarity, but in survival. Every intact piece is a survivor of an industry that had no reason to leave it unharmed. The worth of Hemimorphite is the sum of everything that was sacrificed around it. The tons of ore crushed without notice. The crystals dissolved before anyone looked closely. The deposits exhausted before their beauty was understood. In the silent drawers of mineral collections, Hemimorphite rests as a reminder of how much is taken before humanity learns what should have been preserved. Its delicate, asymmetrical form speaks of a world where fragility is not weakness, but evidence of endurance against overwhelming odds. It is a gemstone not defined by abundance, but by the cost of every piece that no longer exists. Ranked 11th, Obsidian, geometry. Born from an instant, a ceremonial blade slipped from a hand and cracked against stone, breaking cleanly into three pieces on the exposed surfaces. The perfect curves of conchoidal fracture shimmered like engineered geometry, proof that order can emerge from impact. When ancient volcanoes expelled superheated silicate glass into the open air, the molten material froze before it could crystallize. Its atoms locked into position with such urgency that no lattice had time to form. The result was a surface so smooth, so mathematically flawless, that early humans believed it to be the work of something deliberate. Obsidian fractures along lines of perfect predictability. Strike it at the correct angle and it yields edges thinner than a razor, sharper than surgical steel, capable of splitting fibers with no visible tear. Every blade carved by early civilizations across the Americas, the Mediterranean, and the Pacific Islands followed the same principle. Nature had engineered the ideal geometry. Humans only revealed it. Yet for centuries, many of these volcanic glass nodules were broken carelessly, cracked open by miners searching for pumice, shattered by travelers seeking fire-starting stones, or reduced to rubble in quarry blasts. These fragments, thought to be waste, became mosaics of accidental brilliance. When light moved across their surfaces, it exposed hidden symmetries, radial fans, feather patterns, and concentric ripples frozen at the moment of fracture. What was once dismissed as debris is now recognized as one of Earth's most precise natural materials. The internal architecture of obsidian reveals itself only when struck. Conchoidal fractures create curving, shell-like surfaces, the same geometry seen in ancient arrows, ritual blades, and ceremonial mirrors. Each ripple records the propagation of force, a shockwave translated into sculpture. To hold a piece is to hold the memory of pressure, impact, and the physics of breakage rendered elegant. In certain volcanic regions, iron and manganese diffuse through obsidian in microscopic layers. When broken, these layers fan into sheen patterns, gold that spreads like dawn light across a horizon, silver that glides across the stone like the reflection of a distant moon, rainbow bands that appear with the structured regularity of diffraction gratings. These effects are not random. They are produced by nanometer-scale alternations in composition, layered so precisely that some mineralogists compare them to engineered thin-film coatings. Nature, in a moment of volcanic violence, created the optical equivalent of a designed instrument. For centuries, most of this delicate architecture was destroyed before anyone considered its value. Obsidian often appeared in zones targeted for road construction, mineral extraction, or agricultural clearing. By the time scientific curiosity turned toward its microstructures, many beds had been compromised. Its most perfect natural fractures lost to blades, plowshares, and dynamite. Collectors now search for specimens where breakage captured geometric perfection. The most admired pieces are those with deliberate angles, a single conchoidal wave with no interruption, a radial fan meeting at a flawless point, or a mirror surface reflecting light as if it were liquid shadow. Obsidian is valued today not for longevity. It remains brittle, sensitive to pressure, and vulnerable to scratches, but for the precise language encoded in every fracture. Each shard is a diagram, a record of energy, temperature, and the physics of eruption set into silent form. Its worth is measured in architecture, not durability. In museum cases, obsidian gleams like frozen intent, dark, reflective, and impossibly ordered. What appeared chaotic at birth reveals itself as one of Earth's most precise materials, its beauty unlocked not by preservation, but by the controlled act of breaking. Ranked 10th, Chrysocolla, where copper learns to become color. Before Chrysocolla became a tapestry of turquoise, teal, and green, etched across the walls of abandoned mines, it began in silence, in fractures where the earth exhaled the remnants of dying volcanoes. Its origin is a dialogue between copper and water, heat and collapse, pressure and dissolution, each responding to forces millions of years in the making. Chrysocolla forms not in the violence of eruption, but in what follows long after the fire has faded, the slow oxidation of copper-rich veins. These veins, once molten threads running like arteries through mountains, eventually fractured as tectonic plates shifted. Rainwater seeped downward, carrying with it dissolved carbon dioxide. When this water met the exposed copper minerals, malachite, azurite, tenorite, the metal began to surrender, atom by atom. The transformation was not sudden. It happened drop by drop, season by season, in cycles of dryness and saturation. Across centuries, microscopic layers of hydrated copper silicate began to coat the fractured surfaces, forming delicate skins of blue-green gel. With time, these skins thickened, hardened, and merged into bands, each one a chapter in a geological manuscript written without haste. But the true genesis of Chrysocolla lies in variability. This mineral is not one structure, but a continuum, sometimes layered like watercolor washes, sometimes pooled like ancient lakes, sometimes veined with silica so thoroughly that the stone becomes Chrysocolla chalcedony, glass-like, durable, luminous. Its beauty is a record of changing conditions. Where water slowed, color deepened. Where heat fluctuated, textures shifted. Where silica entered the bloodstream of the stone, transparency bloomed like frost inside glass. Every shade, seafoam, aquamarine, desert sky blue, is evidence of chemical negotiations between earth and fluid. Chrysocolla is not born pristine. It emerges from compromise. Yet for centuries, miners viewed it as an unwanted consequence of these reactions. In copper mines across the American Southwest, Chile, Israel, and the Congo, Chrysocolla was scraped away with shovels, its fragile crusts broken as workers carved toward the richer ore below. To them, it was merely the residue of oxidation, a sign that copper veins were thinning. Very little survived the extraction. Most Chrysocolla crumbled long before it reached daylight, its delicate structure failing under the vibration of tools or the weight of machinery. What the earth had spent eons composing was undone in seconds. Only in the late 20th century did mineralogists begin to trace its true lineage, understanding Chrysocolla not as a secondary nuisance, but as a mineral born from one of geology's most patient processes. Collectors followed soon after, drawn to stones where silica had infiltrated deeply enough to stabilize structure without muting color. These rare examples, gemmy, translucent, oceanic, became prized artifacts of geological evolution. To examine a polished piece of Chrysocolla today is to study time layered in color, epochs of drought condensed into pale blues, periods of mineral-rich flooding deepened into verdant green, bursts of silica crystallization captured in glass-like halos. Unlike stones born in magma chambers or metamorphic crucibles, Chrysocolla is created in the aftermath, its formation an act of renewal rather than destruction. It is a stone shaped by the Earth's ability to repurpose its own remnants, turning the collapse of volcanoes and the decay of copper into beauty. Its value lies not only in rarity, but in the improbable conditions required to bring it into being. A mineral that forms only where fire has passed, where water returns, and where time chooses to linger, Chrysocolla is a reminder that genesis is not always explosive. Sometimes it is quiet, a slow accumulation of color in places the world has forgotten, a whisper of chemistry unfolding in the deep, a record of how the earth rebuilds itself after the end of things. Ranked 9th. Smoky Quartz. When fire breaks the rules of stone, most gemstones become what they are through intricate, orderly transformations: heat, pressure, crystallization, cooling. But citrine, in many of its most vivid forms, is born from an event that contradicts the quiet logic of geology. It is the child of disruption, the product of temperatures the Earth rarely delivers, and a testament to an anomaly. That destruction can yield a color that should never have existed in the first place. Deep in the Earth, smoky quartz begins life as a survivor of radiation. Aluminum impurities within its lattice capture stray particles left behind by uranium decay, tinting the crystal with hues of storm cloud and shadow. Its darkness is a ledger of exposure, a long memory of subterranean energy. For millions of years, that darkness remains stable. Smoky quartz does not simply turn into something else, it persists. And yet, a few rare geological conditions manage to force it into transformation. When magma intrudes near quartz-rich veins without fully melting them, when hydrothermal systems surge unexpectedly, when sudden heat pulses strike ancient fractures, the gentle smolder of smoky shifts toward a rising ember. The color warms, the lattice adjusts, radiation scars anneal, and the improbable happens. The stone becomes yellow, not a soft, diffused yellow, but a citrine blaze, honey, flame, sunrise, emerging from a crystal that, by all geological reasoning, should have stayed gray forever. This metamorphosis is so rare in nature that when humans first discovered citrine in quantity, they assumed it was a separate mineral entirely. What no one realized was that many pieces had been altered by accident, by fires lit in old mines, by heat from metalworking forges, by lightning-struck outcrops, even by the deliberate burning of unwanted smoky quartz to purify ore bodies. Unwittingly, people recreated one of Earth's rarest thermal anomalies. In the 19th and early 20th centuries, miners sometimes set controlled fires inside tunnels to open tight seams or clear debris. Smoky quartz caught in the heat of those flames transformed, its shadow lifting, its interior clarifying, its body glowing gold. The change was subtle at first, then unmistakable. When smoky quartz is heated past specific thresholds, trapped electrons return to their original positions, dissolving the smoky hue. Simultaneously, trace iron within the crystal oxidizes, contributing warm tones. The dual mechanism is so specific, so narrow in its thermal window, that only a fraction of heated smoky quartz becomes viable citrine. The rest cracks, clouds, or collapses. The rarity lies in precision. 1 degree too high, the lattice shatters. 1 degree too low, the transformation fails. Only crystals that endure the exact edge of destruction cross the threshold into citrine light. Collectors value these natural and historical transformations for precisely this reason. They are anomalies forged at the boundary between ruin and renewal. A specimen of natural, smoky to citrine carries within it two histories, the dark memory of radiation and the bright aftermath of heat. It is a mineral that has lived twice, each identity written in a different wavelength. In museum displays, these crystals gleam like fossils of fire, reminders that some gemstones exist not because geology intended them, but because the Earth occasionally allows a rule to be broken. What humans once tried to clear away or burn now commands admiration. An accident of heat became a phenomenon of beauty, and in the golden light of citrine, the anomaly that birthed it continues to glow. Ranked 8th, Labradorite, when light breaks its silence. Long before Labradorite earned its reputation as a stone of shifting auroras, it lived in darkness, its colors sealed beneath a surface as plain as weathered ice. To early miners on the coast of Labrador, these dull gray-green slabs appeared unremarkable. They were tossed aside with shattered feldspar, broken shale, and other rubble that collected at the edges of quarries. Nothing about them suggested the presence of spectral fire. But Labradorite is a stone that keeps secrets. Its iridescence, the phenomenon known as labradorescence, does not appear until light enters at the exact angle, at a precise depth, and reflects between internal layers thinner than a wavelength of color. These layers, composed of exsolution lamellae of calcium and sodium feldspar, behave like microscopic mirrors arranged in a disciplined pattern. Only a fracture, a chip, or a clean cut reveals what the untouched surface conceals. And so, the first revelation came from an accident, A discarded boulder split when dropped from a cartwheel. The broken face, still dusted with soil, caught the low angle of the evening sun, and light erupted from within, a pulse of blue like glacial lightning, a streak of gold like a rising dawn, then a flare of green that shimmered as though the stone were inhaling. To witness Labradorite reveal itself is to watch a horizon move. Once miners realized that light was locked inside these unassuming stones, they began breaking them intentionally, not for destruction, but for discovery. The outer husk was merely a threshold. The interior was a phenomenon. Each blow of a chisel became an invocation, an attempt to summon the hidden spectrum lying beneath collectors, later compared the effect to a shutter opening. One moment, silence. The next, a cascade of color that feels less like reflection and more like something waking. But the revelation does not come freely. Labradorite's internal architecture is fragile, its optical layers easily disrupted. Strike too hard, and the lamellae shift or collapse, cut with the wrong orientation, and the spectral field disappears. Only stones cleaved along particular planes release their chromatic depths. Thus, every piece of vivid Labradorite is a survivor of precision, accident, and refusal. Refusal to show its colors until the world approaches it correctly. Some believe the stone's flashes were remnants of northern lights trapped in rock during ancient winters. Others saw them as memories of the sky. Yet the true revelation is geological, not mythical. When feldspar cools at uneven rates, sodium and calcium atoms separate into microscopically layered domains. Each layer bends light differently. Stacked together, they create optical interference. Colors born from the controlled collision of wavelengths. Blue emerges when the layers are thin, greens when thicker, golds when the structure widens into a delicate internal staircase. It is architecture, not magic. And yet, standing before a polished slab that ignites with sweeping auroras, the boundary between the two feels thin. What humans once discarded, misunderstanding its muted exterior, is now revered for the precise interplay of order and light hidden beneath its shell. Labradorite's value today is not born from scarcity, but from revelation, a reminder that beauty can exist fully formed, yet remain invisible until something breaks, or until light arrives in just the right moment. In museum halls, it rests under controlled lamps, each positioned to unlock a different hue. Visitors lean close, watching colors slide across the surface as if drawn by breath. What the earth concealed for millennia, a single stroke of light now unveils. Labradorite does not shine, it reveals. Ranked 7th, Rhodochrosite, beauty formed in a field of conflict. Rhodochrosite is a stone born in quiet chambers, but its history unfolds in conflict. It forms deep within the skeletons of abandoned mines, where groundwater rich in manganese seeps into empty voids. Layer by layer, the mineral precipitates into concentric rings: rose, crimson, coral, raspberry. Each band is the memory of a season underground. Each droplet of mineral-rich water leaves a trace of time. But the tranquility of its formation has never matched the turmoil surrounding its discovery. In the mountains of Argentina, Colorado, and South Africa, Rhodochrosite was first encountered not by collectors, but by miners hungry for metal. They approached the earth with a mandate: remove everything that stood between them and the seams of copper, silver, and zinc locked inside the rock. When drills struck the first pockets of Rhodochrosite, the reaction was not admiration. It was irritation. The stone was soft. It fractured easily. It clogged tools, collapsed under vibration, and threatened the stability of tunnels. Its vibrant pink spheres were smashed aside like fragile shells, their pieces swept away with rubble dense enough to drown them. The most exquisite specimens, stalactites shaped like frozen roses, were often destroyed before a single ray of surface light reached them. Yet the story shifted when a few surviving pieces reached the hands of lapidaries. The polished surfaces revealed patterns that looked impossibly deliberate: bands arranged like the rings of a celestial planet, swirls resembling the cross-sections of ancient corals, hearts blooming within stalactite columns. Word spread. The soft pink stone that once caused delays now caused bidding wars. Collectors called it Inca Rose, believing it to be the solidified blood of royal lineage. Museums displayed the few intact stalactites as botanical ghosts, flowers that had never opened above ground. And with rising recognition came a new tension: the conflict between a stone too delicate to survive mining and a market desperate to obtain it. Rhodochrosite is brittle enough that a misplaced hammer blow can erase a decade of formation. Vibrations from machinery can collapse entire pockets. Even the warmth of human hands can alter its surface moisture. For every perfect specimen that survives, countless others vanish in unseen fractures. In the Sweet Home mine of Colorado, once a source of some of the world's finest rhodochrosite, engineers built elaborate support systems not to protect miners, but to protect the crystal clusters. Extraction slowed to a near crawl. Noise was minimized. Pumps were repositioned. Entire operations pivoted towards saving formations that could be destroyed by a single tremor. Even then, most were lost. Today, the most valuable rhodochrosite is defined not by size or color alone, but by survival. A vibrant red slice with unbroken concentric rings can command museum-level reverence. A stalactite column, perfectly intact from tip to core, is considered geological luxury, preserved against a world designed to crush it. Rhodochrosite's beauty is inseparable from conflict. It is the stone that the earth grew in peace and humanity struggled to approach without breaking. Its value is shaped by tension, between what the earth offers and what extraction threatens, between fragility and desire, between the deep past and the hands reaching toward it today. And in that tension, rhodochrosite endures. A rose carved by pressure, guarded by danger, and forever marked by the conflict that defines its existence. Ranked 6th, Larimar, the lost sky of the Caribbean. Before it had a name, before it shimmered in markets as the Atlantis stone, Larimar existed as an inheritance the world forgot to claim. Its history begins on a small island where mountains rise like sleeping animals, their spines carved by rivers, their flanks scarred by extinct volcanoes. Buried within the folds of the Dominican Republic's serpentine terrain, pale blue silicate formed slowly, one pulse of hydrothermal activity at a time, until the stone resembled pieces of sky that had solidified underground. But Larimar never announced itself. It hid inside basaltic prisons, behind walls of rock so dense that even miners walked past without knowing what waited only an arm's depth away. The first chapter of its legacy is absence. Indigenous Taino communities once collected fragments, washed onto riverbanks after storms. They wore the blue stones as charms, believing them to be droplets of the ocean given permanent form. Their songs spoke of a sky trapped in stone, a gift of protection carried from generation to generation. But the source of the mineral remained unknown. When the Taino population collapsed under colonization, the knowledge went with them. Larimar's legacy dissolved into myth. For centuries, the stone disappeared from memory. Then came the rediscovery, a moment not of triumph, but of curiosity. In the 20th century, a local priest walking along a storm-scoured shore found bluish pebbles glinting between driftwood and shells. He traced them upriver, following the path the Taino had once followed, until the trail ended at a landslide. The cliff face had ruptured, exposing veins of blue hidden for generations. The heritage returned by accident. Early attempts to extract Larimar were clumsy. Miners fought through basalt walls with hand tools, unaware of how easily the stone fractured. Large nodules shattered upon removal. Finer patterns were lost with a single misplaced strike. For every polished cabochon in a jeweler's tray today, countless pieces were broken in the struggle to pull them from the earth. Larimar became known as a stone shaped not only by geology, but by loss. Its finest material, those gemmy, cloud-veined blues that resemble the shallow Caribbean, forms only where silicate gels cool with exacting slowness. Too little heat and the blue fades. Too much and the stone becomes chalk. Only a slender window of temperature allows Larimar to crystallize into the intricate lattices that scatter light like frozen wavefoam. That narrowness made the stone rare. Mining made it vulnerable, and scarcity made it precious. Today, the most coveted Larimar is not simply vibrant or clean. It is patterned with the geometry of Caribbean waters. Webs of white that resemble sunlit ripples, bands of blue shifting from sky to sea, cells of color that mirror tide pools glimpsed from above. These patterns are not artistic illusions, but geological calligraphy, written by mineral solutions draining through volcanic tunnels millions of years ago. Its value today is inseparable from what disappeared. The cultures that held it, the knowledge that named it, the deposits already exhausted by mining, the rivers that no longer carry blue pebbles to the sea. Larimar's legacy is a reminder that some treasures endure not because they were preserved, but because the earth allowed them to be found again. Between the fractures of black basalt, sky-colored stone waits for those who still remember to look. Ranked fifth, Pyrope Garnet, the fire that collectors cannot resist. At a small mountain market, a bead-sized red gem provoked an argument so fierce it toppled an entire display stall. None of the traders knew it had once been thrown into fire, only that its ember-red glow pulled eyes back again and again. Its story does not begin in museums or mineral halls, it begins in the mouths of furnaces. For centuries, miners misidentified pyrope as fragments of iron-rich rock or as dark, unremarkable stones tangled in coal seams. Many pieces were shoveled into smelters alongside fuel. Some were swept into slag piles where heat distortion melted the edges into glassy red blisters. No one imagined that the very fire meant to erase them was transforming them instead. Only later, when shattered slag revealed flashes of deep crimson, did collectors notice a disturbing pattern. The most vivid pyrope, the ones glowing with the color of embers held beneath a breath, were almost always stones that had survived extreme heat. Once the mistake was understood, obsession took root. In the 19th and early 20th centuries, gem hunters scoured abandoned smelters for overlooked pyrope. They sifted through ash heaps and slag mounds with the same intensity gold seekers applied to riverbeds. Factories were trespassed after dark kilns were dismantled, stone by stone. Miners sold handfuls of fire-born garnet to travelers, the way rare spices once passed through desert caravans. The market's desire grew stranger still. Collectors sought not perfection, but damage. Stones whose clarity carried the ghost of heat, whose internal inclusions folded like cooled magma, whose reds held a depth that ordinary pyrope could never match. It was obsession over the unmistakable color, a red so dense it seems lit from within, a shade evoking coals in their final glow, a hue impossible to replicate without the risk of destroying the stone. The gemological truth is subtle but real. Under intense thermal stress, the iron-rich lattice of pyrope adjusts. Some inclusions dissolve, others sharpen. Chromatic saturation deepens as if the stone condenses its pigment. The result is a variety of garnet that looks neither natural nor artificial, but transitional, as though it carries two histories, one geological, one forged in flame. Dealers began ranking specimens by heat signatures. Smaller stones with glass-like luster fetched prices rivaling ruby larger ones, especially those recovered from industrial sites, became tokens of a collector's willingness to pursue rarity through unconventional means, and still the appetite grew. Stories circulated of garnet hunters crossing into decommissioned mining tunnels at night, searching for pockets of pyrope that machinery had fractured but not incinerated. Some risked collapsed zones. Others bribed smelter workers for access to sorting tables. The pursuit became ritualistic, more quest than commerce. Today, the obsession remains, though the landscape has changed. Abandoned smelters have been sealed. Ash heaps have been stripped bare. What survives sits in private vaults, auction houses, or under museum glass, each stone labeled with its dual legacy, born of earth, refined by fire. A fine pyrope is no longer just a gemstone. It is a relic of human error transformed into beauty, a reminder that desire often grows strongest when it follows a path not meant to be taken. Collectors speak of a strange magnetism inside these stones, a pull that has nothing to do with mineralogy and everything to do with hunger, for rarity, for narrative, for possession. Obsession is not merely part of pyrope's history. It is the force that defines its value. For in the world of gemstones, few things are more coveted than beauty created by accident and pursued without restraint. Ranked fourth, Spinel, the gem that wore another name. For most of its history, Spinel lived beneath the shadow of another name. It gleamed in royal crowns, imperial treasures, and sacred relics, yet it was never granted its own identity. Jewels that shone with its light were attributed to a different stone, ruby, the sovereign of red. Thus, Spinel entered the world's great collections not as itself, but as an impostor no one intended to deceive. The misunderstanding began centuries ago, long before chemistry, spectroscopy, or crystallography existed. Gem cutters judged stones by eye, by instinct, by the way light moved within a facet. And Spinel, with its crisp transparency and perfect octahedral growth, imitated ruby so convincingly that even kings could not discern the difference. The most famous, the Black Prince's ruby set into the imperial state crown of Britain, is not a ruby at all. It is Spinel, unrecognized for centuries. Revelation came slowly, quietly, like the clearing of a lens. When early mineralogists noticed that some rubies lacked the hexagonal symmetry characteristic of corundum, questions emerged later. Flame tests and spectroscopy revealed a divergence in chemistry. Ruby carries chromium, Spinel carries magnesium and aluminum. One belonged to corundum, the other to its own distinct species identity, once assumed, was corrected. This revelation redrew the map of gem history. Stones believed to be ruby heirlooms, gifts between empires, trophies of war, symbols of dynastic power, were suddenly recognized as Spinel, not lesser, not counterfeit, but different, unseen, uncredited. And with that recognition came a second revelation. Deeper and more startling, Spinel, liberated from comparison, revealed qualities ruby could not replicate. A purity of saturation untouched by rudal silk, an ease of brilliance that slices through shadow, a crispness of facet junctions that gem cutters compare to glass under tension. It is a stone of clarity, optical clarity, historical clarity, and the clarity that comes when something long misunderstood finally emerges defined. Yet Spinel paid a price for its centuries of mistaken identity. Because it was considered ruby's lesser twin, countless fine specimens were discarded, heated, recut improperly, or destroyed in attempts to match the ruby standards. It never belonged to human error, erased a portion of its geological story before that story was known. Only in the modern era did collectors begin to pursue Spinel for what it truly is. The Renaissance began with the discovery of vibrant red crystals in Burma's Mogok region. Stones glowing with a hue gemologists call stoplight red, a color so sharply saturated it seems to radiate outward. Then came cobalt blue spinels of Sri Lanka and Vietnam, gems so electric they shifted the entire color vocabulary of the mineral world. Prices surged, catalogs corrected. Museums revised placards written generations earlier. The world was learning a simple truth. Beauty misnamed is still beauty, but beauty reclaimed is something more powerful. Spinel's revelation is not only scientific but philosophical. It reminds us how easily identity can be obscured beneath assumptions, how long the truth can sleep beneath a borrowed title, and how profound the moment becomes when recognition finally arrives today. Spinel stands unapologetically under its own name. A gemstone no longer mistaken, no longer overshadowed, no longer silent. Its value has risen not through rarity alone, but through the revelation of everything it always was, and the acknowledgement finally given in correcting its identity, the world restored its worth. Ranked third, Moldavite, what fell from the sky, humanity buried. Shallow pits scarred the forest floor like unhealed wounds. Each cavity marked a night of illicit digging, the terrain torn open in pursuit of green glass born from a prehistoric collision 15 million years ago, a meteorite the size of a mountain torn to the earth near what is now southern Germany. The collision vaporized rock, soil, and forest, launching molten material across hundreds of kilometers. As this incandescent rain fell, it cooled into droplets of glass, green, translucent, twisted by the violence of their birth. These droplets became Moldavite, a gemstone born not from earth alone, but from the consequence of something striking. Its geological origin is violent, but its human history is defined by fear. In small villages across Bohemia and Moravia, Moldavite was long viewed with suspicion. Its shapes, wrinkled, etched, alien, did not resemble the stones of familiar soil. Some pieces looked like frozen smoke, others like splintered tears. No one could explain their sudden appearance near riverbeds after storms. People buried what they found. Some believed Moldavite carried misfortune. Others thought it was a remnant of lightning or a curse left by wandering spirits. For generations, the green stones were thrown into wells, buried beneath thresholds, or discarded in forest clearings. What was misunderstood was lost, but the greatest consequence came not from fear, but from curiosity. In the 19th century, when mineralogists realized Moldavite was the product of an ancient impact, curiosity erupted into frenzy. Collectors sought the stone not for jewelry, but for what it represented: a physical trace of an astronomical event, a piece of the sky that had once collided with Earth villages, that once discarded Moldavite saw strangers combing their fields with sieves and lanterns at night. Farmers sold small pieces to travelers. Children searched riverbanks for pocket money. The landscape that had hidden Moldavite for millennia was suddenly exposed to relentless hands. Then came the modern wave, the consequence of belief. In the early 21st century, a global surge in metaphysical trends propelled Moldavite into a spotlight no scientific mineral had ever experienced. Videos, stories, and rumors transformed it into a stone of awakening, transformation, even upheaval. Demand soared beyond reason. What followed was a new kind of destruction. Collectors dug private land without permission. Entire fields were overturned. Forest floors were stripped bare. Poachers tunneled into protected reserves under darkness, hauling sacks of soil toward riverbanks to wash them in secret. The ground eroded. Roots collapsed. Wildlife habitats were scarred. Where Moldavite once lay scattered naturally, the earth became pitted with holes. The consequence of obsession meeting scarcity. And scarcity came swiftly. Only one region on Earth produces true Moldavite, a thin band across the Czech Republic. Tied directly to the ancient impact zone, no new Moldavite will ever form. Every stone mined, lost, or broken reduces a finite supply. Today, the finest pieces, crisp, fern-etched, forest green, command prices once unimaginable. Collectors bid for stones with sculptural ridges formed by the chaotic cooling of molten ejecta. Museum-grade hedgehog specimens, once common, now surface only in private estates or old scientific collections. Moldavite's value is the sum of every consequence that shaped it: the meteor that created it, the fear that buried it, the craze that dug too deeply, and the final realization that what remains is all that will ever exist. In its green translucence, the past is visible: fractured pathways of molten glass, microscopic bubbles of ancient air, the imprint of an impact no human witnessed. And in its scarcity, the present is equally clear. Some gemstones become rare by nature. Moldavite became rare by consequence. Ranked second, Serendibite, the gem lost to the blades that sought it. A stone-cutting saw halted mid-slice, revealing a thin black streak across the marble slab. No one noticed the dark vein, nor realized that with every cut, one of Earth's rarest minerals was being erased. Its story begins in the embattled quarries of Sri Lanka and the metamorphic folds of Myanmar's Mogok Valley, where generations of miners carved relentlessly through marble and skarn in pursuit of blue sapphire. To them, every layer of rock was either a gateway or an obstacle. What could be cut, they cut. What resisted, they crushed. What interrupted the hunt was cleared away without hesitation. Serendibite was born inside these obstacles, woven into calc-silicate seams, threaded through marble like ink through paper. Its crystals, small and easily overlooked, carried colors that shifted between ink blue, bottle green, and midnight black. But in a landscape obsessed with sapphire, its presence meant little to most miners. Serendibite was simply hard waste. Too dark to resemble gem material, too tough for hand tools, too brittle to survive dynamite. It was sacrificed by default. When machinery struck it, Serendibite split into razor-edged fragments. When explosives blasted the surrounding rock, the crystals shattered into powder. When marble blocks were sawn into slabs, thin veins of serendibite were erased beneath the teeth of rotating steel blades, obliterated so completely that no one realized a mineral rarer than sapphire was disappearing beneath every cut. The first documented pieces of gem-quality serendibite surfaced not from miners, but from geologists who noticed strange tiny grains embedded inside marble offcuts. Under magnification, these grains displayed unusual pleochroism, shades shifting with every turn of the crystal. Only then did the truth emerge, a gemstone so scarce that its entire global presence could fit in the palm of a hand had been destroyed for decades, perhaps centuries, without ever being recognized. The greatest irony is that serendibite's rarity was created by human hands. Nature formed it in micro-pockets, mineralogical asides within the grand story of sapphire, but mining eliminated those pockets almost as soon as they were revealed. Outcrops vanished, tunnels collapsed, marble faces were ground smooth for construction. Every polished tile sold around the world with a faint dark vein likely bears a trace of what serendibite once was, a signature of a gem crushed before anyone saw it. By the time collectors began searching for intact specimens, the damage was done. Entire quarries had been emptied. The few pieces that survived were salvaged from rubble or found embedded in abandoned blocks, destined for sculpture. Most were smaller than a fingernail. Gem-quality fragments larger than a seed were celebrated as geological miracles. The market responded with a mixture of reverence and regret. Serendibite became a symbol not of abundance, but of extinction. A gemstone whose value rises not because nature withheld it, but because humanity erased it faster than it could be studied today. Only a handful of cut serendibite gems exist. Each one is a relic of what extraction destroyed. A survivor of saw blades, hammers, and dynamite. A piece of night sky rescued from the ruins of marble walls. Its luster is subdued, almost solemn. Its tones are dark, as if carrying the memory of the quarries that consumed its kin. There is no flamboyance, no fire, only depth, density, and the quiet weight of something nearly lost. Serendibite's beauty is inseparable from sacrifice. It is the stone that the earth formed in secret and industry erased in ignorance. What remains is not merely rare. It is everything that managed to stay intact in a world built to destroy it. In first place, Taaffeite, a gem found only after it was lost. A small violet gem rested beneath a desk lamp, carrying no trace of the rock it came from. No mine, no matrix, no geologic memory, only existence. The lone remnant of a mineral nature seemed to have withdrawn from the world. In 1945, a gem cutter in Dublin examined a small, lilac-colored spinel from an unremarkable parcel of Sri Lankan stones. Its facets were plain, its glow modest, its origin indistinct. Nothing about it suggested singularity, but the light behaved strangely, splitting subtly, whispering of a structure that Spinel did not possess. What the gem cutter held was Taaffeite, though no one knew the name yet. And what made the discovery extraordinary was this: the gemstone had already been cut. The rough it came from, the original mineral, the untouched form, was gone. Taaffeite arrived into human understanding only after the world had unknowingly destroyed every trace of its natural beginning. This is the silence at the center of its identity. A mineral introduced not by the earth, but by the last surviving fragment of something already lost. For decades, no one could find its source. Geologists searched the river gravels of Sri Lanka. They sifted the soils of Ratnapura and traced the flow of ancient alluvial paths. They questioned miners, cutters, and traders, searching for even the smallest clue. Nothing. Taaffeite, for a time, existed only as a single-cut stone, a gemstone without a birthplace. Years passed before another appeared, then another. All of them already cut, already altered, already separated from the stone that once held them. Even today, Taaffeite is found not by mining veins or opening quarries, but by re-examining parcels of gems meant to be something else. Its rough is almost never seen. What few crystals emerge are fragments, ghosts of geology, disrupted long before their identity could be recorded. It is a gemstone with no origin story we can witness, Only one we can infer through absence. Taaffeite's structure reveals what the Earth intended: a delicate balance between magnesium and beryllium, a lattice rare enough to form only when conditions align with improbable precision. One trace element shifts, and the mineral becomes spinel. Another shift, and it collapses into chrysoberyl. Taaffeite exists in the narrowest sliver between them, a mineralogical breath held only for an instant. What survives today are the pieces that escaped recognition long enough to be cut intact. They bear no record of their place in the earth, no matrix, no host, no history of pressure, just the calm violet glow of something rescued from oblivion by a fortunate mistake. Its value rises not from flamboyant color or dramatic brilliance, but from silence. The silence of missing rough, missing deposits, missing accounts, missing witnesses. Taaffeite is a mineral that introduced itself only after the world had already erased its tracks. Collectors approach it with an unusual reverence. There is no mine to visit, no tunnel to map, no cliff face to study. What one sees is all that will ever be known. Every specimen is a closed chapter, a page torn from a book whose remaining volumes have been burned. In museums, Taaffeite rests in quiet corners, its presence almost understated, a small violet glint, a placard with more questions than answers, a suggestion of a story the earth told once, softly and then withdrew. And yet, within that absence lies its power. Taaffeite is not the rarest gemstone because nature withheld it. It is rare because humanity did not realize it existed until the earth had already stopped offering it. It is a reminder that beauty can be finite in ways we do not anticipate, not through depletion or overuse, but through silence, through the fragility of moments in geological history that do not repeat themselves. The world tried to grind it away, misidentify it, cut it into anonymity. But the small fragments that survive became more valuable precisely because they are the remnants of a mineral that nearly vanished before it was ever understood. Taaffeite's story ends as it begins, with a quiet glow, a faint lilac light emerging from the place where knowledge meets the edge of the unknown. A gemstone defined not by what it shows, but by everything that is missing. The stories end where the light begins to fade, but the stones remain. Fragments of color shaped by fire, impact, misunderstanding, and by the hands that nearly erased them. Each one carries a silence of its own, a mark of what was lost, a memory of what survived, a reminder that value often emerges from the edge of disappearance. As we leave these 15 survivors behind, the earth continues its slow work beneath us, forming, dissolving, rebuilding, writing new chapters we may never see. If this journey has shown anything, it is that beauty is not guaranteed. It can be broken, misnamed, buried, or forgotten, yet still return with unexpected resilience. Thank you for spending this time in the quiet world beneath the surface. If you wish to walk further into these hidden histories, you are welcome to stay with us, to subscribe gently, and to visit again when the next chapter of Earth's secrets is ready. Which stones stayed with you the longest after the light faded?